So this next section is really just applications of rational functions. So we're going to have some word problems. We're also going to see just kind of how to manipulate some equations. We're going to work through just two kind of topics. First one we're going to look at is just how these rational equations or expressions can appear in our sciences. And then we're also going to talk about proportions. And then our next unit is going to build more on that proportions aspect. So the first thing we're going to go through is we're going to work with some formulas that appear just in our everyday sciences. So if you have to take chemistry, if you have to take physics, these will kind of appear later on. And what we're going to do is we're going to solve each of these equations for whatever variable they want. So we just got to do a lot of manipulation. So this very first equation is really about gravity. So it's force, G is gravity, M is mass, and D is a distance. So if you take physics, you might see this equation pop up. So each of these variables has some real kind of interpretation. And what we want to do is we want to manipulate this equation to solve for this variable of G. So we're just going to apply all the skills we have to manipulate. I'm going to go ahead and I'm going to add some extra little operations just so we can see what we have to do. So I want to isolate this variable. Looking at this expression, first thing I want to do is I want to get rid of this fraction. So I want to multiply the d squared to the other side. So we're going to multiply this side by d squared, which means we have to do the same thing over here. So that will make those two cancel out. On the left-hand side, we'll have f times d squared is equal to g times capital M times little m. And now here, in one nice swoop, to get rid of these two variables because they're being multiplied, we go ahead and divide. And what we do to one side, we have to do to the other. So that makes these two cancel each other out. We're left with fd squared over capital M, little m, and we have isolated this value of G. Okay. In this next equation, we've got really the same letters, but some are capital, some are not. This is actually some kind of gas law, so P is standing, I believe, for density, V is for volume, and I think this is temperature. So based on the temperature, the density, the volume can expand depending on whatever type of substance you're dealing with. But things do have to remain constant. So we want to solve this for this value of little t. So unfortunately, we have a ton of fractions. You have quite a few ways that you can actually go about this one. You can flip both fractions from the very start if you want, since it is a single fraction equals a single fraction. I think the more natural thing that people want to do is we can go ahead and wipe these fractions by cross multiplying. So we have capital P, capital V times little t equals little p, little v, and capital T. And now I want to get t by itself, so I have to get rid of this p times v. So I'm going to go ahead and I'm going to take both sides and I'm going to divide it by capital P and capital V. And that makes those two cancel out on the left, and we're left with little t. Now we have little p, little v, capital T over capital P, capital V. So just be careful when you're inputting these. Make sure you have the right stuff capitalized. And so let's try one more. This one is actually the area of a trapezoid. We have the area is equal to 1/2 times the height times the sum of these two bases. And we want to solve this equation for little b. Okay. And again, I got a couple ways that I can do this one. It might look slightly different at the end. I'll show you what you can do. 2 ways at least. but we need to get little b by itself. So I need to get rid of these two things. We definitely do not like fractions and fractions though. So I'm going to start just by getting rid of this 1/2 first. So I'm going to take this and I'm going to multiply it by 2, which means we're going to do the same thing over here. So that will make the 1/2 and the 2 cancel. So this gives us 2a is equal to h times little b plus big B. Okay. You could at this point distribute the h out and then go ahead and solve for that. But I personally think now we need to get b on its own. So let's go ahead and divide by h. So those two cancel each other out. On the left, we have 2a over capital H is equal to little b plus big B. And then from here, we need to subtract b. Unfortunately, on the left, you can't actually do that subtraction. So it's 2a over h minus capital B equals little b. Okay. So that's one way you could do it. Or back at this step, I still like going and multiplying by 2 first. What we could do is we could distribute this h out. So this is 2a equals h times b, h times capital B. And now I still want to get little b on its own. So we subtract the hb. And that gives us 2a minus hb equals h little b. And then from here, to get rid of this h attached, we divide by it. And so it gives us 2a minus h capital B over h equals our little b. And so we have solved for that one base. So you get the same thing, it just looks slightly different, but honestly, these are exactly the same. If you condense this one to a single fraction, you would see this. Or if you split this fraction up, those two h's would cancel out, and you'd get this one over here. So it's really exactly the same thing. So before we get to proportions, let's do one more example working with these kind of formulas. When you're dealing with any types of electrical currents, dealing with that voltage, this formula often appears. And so what we want to do is based on these two values, if A is equal to 8 and C is equal to 12, we want to figure out what does this value of B need to equal. So what I want to do is I want to plug in those given values. So A is 8. B, we have absolutely no idea, and C is going to be 12. Okay. And you could solve this quite a few different ways, but me personally, I hate having all of these fractions. So what I want to do is I want to multiply by the least common denominator. And in this case, for the two numbers, I need a number that's divisible by 12 and 8. So the number that pops into mind for me is 24. If you did a higher number, that's okay. You'd still end up getting to the same answer. Like if you couldn't think of one and you did 8 times 12, that works too. You're just going to have more simplification. And then we also need to multiply by B to get rid of this denominator. So I want to take this entire fraction and I want to multiply it by 24b. So we have 24b times 1 over 8 equals 24b times 1 over b plus 24b times 1 over 12. So on the left-hand side, if you take 24 and divide it by 8, that leaves you with 3. So we have 3b times 1 on the left. Over here, the b's cancel, so we're left with 24. And then last but not least, 24 over 12 is 2. So we get plus 2b. And now we want to get b on its own, so let's go ahead and subtract it. That leaves us with a single b equals 24. And that's exactly what we want. This is what the value of b needs to equal so that the equation is satisfied. So last but not least, the very last topic that we're going to go through is about ratios and proportions. And again, we're going to touch on this a lot more in the next section. So I'm not going to do a ton of problems. Definitely in your homework, just sit there, try things out to the best of your ability. So we're often working with ratios just in the real world. And it's really comparing two quantities. So we can say the ratio of A to B is this thing. And it can be written in a ton of different forms. You could say A to B, A divided by B. We use a colon as well to indicate that it's some kind of ratio. So these appear in just our everyday lives. If you're mixing like pool chemicals or if you're doing cleaning supplies, you need like a 3-to-1 ratio of bleached water for whatever you're doing. Your chemicals in your pool, same kind of thing. When you're dealing with like gambling, you're going to hear ratios pop up a lot. So when you're dealing with sporting events, they talk about the odds of someone winning. These are all really some kind of ratios. Now, what we're specifically going to be working with are proportions. And so a proportion is just some kind of statement that two ratios are equal to each other. So if you're dealing with similar triangles, if you remember way back when dealing with geometry, if you take something and scale it up, you can create proportions out of that. And so in all of your homework, you're going to be setting up some kind of proportion to solve for an unknown quantity. So I'm just going to do one example of how to set up a proportion. In a math class, 3 of every 4 students are girls. If there are 28 students in the class, we want to figure out 2 things. We want to figure out how many are girls. And then if we figure out how many girls, it shouldn't take us too long to figure out how many are boys because we know how many students there are. So our number of girls is an unknown quantity. So I'm going to call that a variable. Let's let x equal the number of girls. Okay. So I want to set up some kind of proportion. So we're setting up really 2 fractions equaling each other. And you have a ton of options as to what you put in each spot. But this one ratio they give us is every 3 of 4 students are girls. So I definitely want to set up a ratio involving that 3 to 4. Okay. And so what I want to recognize is this top one, the 3 is saying every 3 of 4 students is girls. So the top is girls and the bottom is the number of students because it's 3 of 4 students are girls. So now I can set this up as a equation using the fact that there are 28 students in the classroom. So on the right hand side, I don't want to mix anything up. I still want to put number of students in the bottom and I want to put number of girls up top. Okay. The thing is, I don't know how many girls there are, so that's where my missing variable x goes into play. But I do know my total number of students is 28. So if I take x and divide it by 28, number of girls out of 28 students, it better equal 3/4. And now from here, we just want to solve. You can multiply by the least common denominator if you want. But again, I think the natural thing when you see these equal to each other is we really just want to cross multiply to get rid of these fractions. So I'm going to go ahead, cross multiply. So we're going to get 4 times x is equal to 3 times 28. So 4x will equal 84. And then dividing by 4 gives us that x is going to equal 21. So there are 21 girls in the classroom. And now that we know there are 21 girls, there's 28 kids in total. If I take the number of students in total and subtract the number of girls, that tells me there are 7 boys in the classroom. Okay. So definitely sit there, think about these problems. Don't just jump right into trying and looking at the solution. Take your effort and go through each of the problems to the best of your ability first.